Hello, we're going to finish Unit 6 review on quadratic relations today. Today is Wednesday, June 17th. Note number 1. When the points curve in a smile or a frown, these points represent a quadratic relation. So a smile or a frown. Okay? They represent a quadratic relation. If you have a highlighter, you might want to highlight that. Points, when points follow a line, so they create something like this, or they create something like this, they represent a linear relation. Example 1. Using the guess method, use Desmos to draw a scatter plot of the data. Determine if the relationship is best described by a linear or quadratic relation, y. Okay, steps for using Desmos. These are the same steps that we used in an earlier lesson in Unit 6. First, we're going to Google Desmos and click Start Graphing. Second, we're going to click the plus symbol in the top right corner. Then we're going to click on the table icon. Third, we're going to type in the first x value and press the arrow down button to move down the table of values to type in each x value. Fourth, press the right arrow button and the arrow up button to move to the top of the y column, then type in the first y value. Fifth, press the arrow down button to move down to the next row and type in the next y value. Continue until all y values are entered in the table of values. Okay? So guess. So what are we given? We're given a table of values. Okay, we know that's Tav. Unknown. It says use the guess method to use Desmos to draw a scatter plot. Okay, so use Desmos to draw a scatter plot. Use Desmos to draw a scatter plot. Now, a scatter plot is points on a grid. That's all it is. Okay? So we're going to draw these points on the grid using Desmos. Okay, so that is the first thing they're asking us to do. Second verb, determine if the relationship is linear or quadratic. Okay? So second, determine if relationship is linear or quadratic. And then the last part is the question why. Okay, so the equation is based on the steps for Desmos. So follow the steps for using Desmos. Okay, that's there. Okay, number 2, we have to consider how do we determine if the relationship is linear or quadratic. So if linear, go back up here, points follow a line. Points follow a line. If quadratic, there's a smile or a frown. Points curve. Excuse me. if quadratic points curve in a smile or a frown. Now, this takes care, these statements take care of the answers y, right? We're saying y because the points follow a line. We're saying y because the points curve in a smile or a frown. So the solution is C Desmos. Okay, so let's do that. Alrighty, so we're at Google and we're following the instructions. Okay, it says steps for using Desmos. Google Desmos, so we'll do that. Google Desmos. Where's my Google page? Oh, there it pops up over there. Click on that. Click on that. And then we go to the start graphing part. Okay. So it says Google Desmos and click start graphing. Click the plus symbol in the top right corner, then click on the table icon. So the plus symbol, and then the table icon, and there we go. So we're next to type in, number 3, type in the first x value. Type in the first x value and then press the arrow down button to move down the table of values to type in each x value. Okay, so let's do that. So we have x values. Now your textbook question will not have this. It won't have that. And in fact, I took that away from your handout, okay? So because this is listed first, okay, this is first is x. And this is listed second. Oops, this is listed second. So second is y, okay? So I took that out as well because they don't have this in your question, right, that you do in the textbook, okay? But the fact that this comes first means this is x, and because this comes second means it's y, okay? All right, so we have y values and x values. So x goes from 0 to 1, all in order. So we're just going to type in 0, arrow down, 1, arrow down, 2, arrow down, 3, arrow down, 4, arrow down, 5, arrow down, 6, arrow down, 7, arrow down, and 8, arrow down. Okay. And then I feel like I have a different question. Do I? Ah, I do. Okay, so let's do that. I gotta use these so I don't. Oh, change of plans. Okay, let's start that. Okay, so we want to use these values here. There we go. That's better. Okay, so this matches what you have. So notice that this was first. Okay, so that's x. This is second. That's y. This is first. That's x. And this is second. That's y. And I think I took these off here. Okay, so we have values of that we have to change. So let's see if we can do that. Let's do delete. So arrow up, delete, arrow up, delete, arrow up, delete, arrow up, delete, arrow up, delete. Oops, 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 oops. Delete, arrow up, delete, arrow up, delete, arrow up, delete. Okay, so we're going to have to read those off. I'm going to read those off, but I'm going to keep my video showing the table as it's created, right? So it's going to be 0, 3.2, 4.8, 6.4, and 3.2. Okay, so we're going to move our next step is number 4. Press the right arrow button and the arrow up button to move to the top of the Y screen, and then type in the first Y value, so it's 0, 5, 10, 5, 0. So it's 0, 0, 5, 10, 5, 0. Okay. So move over here. What do we have? So we've got that number should be I'm going to fix this here. So 9.6. So I'm going to fix that here. And I'll fix that on your, there. Okay, so 9.6 is what we're going to use. 9.6. Okay, so take it over here. If we want to zoom out, we can. It looks like a little bit of a smile, or a frown, I should say. A little bit too... See if we can... Looks more like a triangle, doesn't it? It's close to a smile. It's not exactly, right? And I'm just using my cursor to zoom in and zoom out, right? We can do like that, like that. So it appears quadratic. It appears like a frown. It's not perfect, right? So we're gonna type in, oops, a daisy. Let's move over here. There we go. So, solution, since the points are close to looking like a frown, therefore the relation is quadratic. Okay, it's really close to looking like a frown. It's not perfect, but when you have scatter plots, right, they're never going to be exactly perfect. All right. All right. So let's try B. Oh, move that one over. Alrighty. So given table of values. U, the unknown. Use Desmos to draw a scatterplot. To draw a scatterplot. Okay, number two is determine if the relationship is best described by a linear or quadratic relation. Determine if the relation is linear or quadratic. And the third question is why. Okay, all right, ESS. Okay, so E. So if we're following Desmos steps, right, that would be one of our pieces of information. So again, take what you have here to inform your equation. So follow the steps for using Desmos. Okay, number two, if we want to address point 2 and 3, we want to say if linear, I'm going to go back to what we highlighted, points follow a line. Points follow a line. And then if quadratic, we have a smile or a frown. If quadratic, points curve, we might want to add that to our highlighting. Points curve in a smile or a frown. Okay, and then S, so we're going to see Desmos. All right, back to Desmos. So we have to take these away. So put our cursor over there. Delete. And then arrow up. Delete. Arrow up. Delete. Arrow up. Delete. Arrow up. Cursor over. Delete. Cursor down. Delete, cursor down, delete, cursor down, delete, cursor down. Okay, so going back up to the X values with my cursor. All right, so what are the values? So they go 0, 1, 2, 3, 4, 5. So that can be typed in by memory. So 1, 2, 3, 4, 5, and then arrow over and then up. And then we've got 0, 7.5. So we've got 0, arrow down, 0.75. We've got 1.5, 1.5, and we've got 2.25. 2.25, then we've got 3, oh, I just noticed something. Okay, we've got 3. Now see how, this is important, so see how the number of rows are equal, right? So I've gotten to 3, I still have one more row, but see how that's not the same as over here? Right? So then I say, well, what did I do differently? Okay, so are my Y values 0? Yes. Is it 0.75? Yes. Is it 1.5? Yes. Is it 2.25? Yes. Is it 3? Yes. Do I have a next one which is 3.75? Yes. Right there. So 3.75. So that means that I have to check my x values. So go over to your x values. Okay. And then say, okay, did I have a 0? Oh, that's missing. Okay, so then I just overwrite them. I 0, cursor down, type in a 1. It replaces the newest value that I type. Okay? I mean, if I want to, I could delete them and then type it, but I don't have to. Okay, so then over there, that is definitely a line, right? So you go over here. It's definitely a line. Okay, so our solution, since the points lie or follow, we'll use the same terminology that we did up here. Okay, so follow a line, follow a line, therefore the relationship is linear. Okay, so that sentence is answered by the y. So this part there, that's the y, the answer to y. Right, that's that right there. And this is also the answer to the y. Answer to y. Right, that phrase there. Okay? Alrighty, let's flip the page. Note number 2. What is a quadratic relation? A quadratic relation has a graph called a parabola. The parabola looks like a smile or a frown. A quadratic relation has an equation like y equals negative x squared plus 4x minus 12. The equation includes y that has an exponent equal to 1. Okay, so that's where the 1 is, understood to be there. And the largest exponent of x is 2. So this is an exponent of x, which is 2. This exponent of x is 1. The largest exponent is 2, because 2 is larger than 1. Okay? Note number, well, I should say 2. There are 5 key features of a quadratic relation. So we did this in earlier lessons. We will use the graph of, and we're going to use this graph of y equals negative x squared plus 4x minus 12. And then that's not above, okay, to state the 5 key features. The 5 key features are y-intercept. Y-intercept is the y value where the graph crosses the y-axis. I'm going to change this. I'm going to take that out of your lesson. Okay, so don't worry, that'll be gone. X-intercept, and x-intercept is the x value where the graph crosses the x-axis. Take that out. Okay, so these are just reminders. Axis of symmetry. Actually, I'm going to have to stop here.